Redox here. I know it's been 3 or 4 weeks since I posted a video, and I know how to use a lavalier mic properly, and we're here back. The response has been awesome. I have just crossed 589 views as per recording. It's awesome. And now, as I told in the last video, the next video is supposed to be tech. See you guys in the next video, which will most probably be tech. The Sony NW-A46HM, the music player we unboxed, but I haven't had enough time with it so that I could give you guys a proper review. So I'm back here with some space. So all the information I've got in this episode is from Exploring the Sky, written by Richard Mosier. So we're gonna look at some random facts again. So this whole series will be random facts. So let's get started. The word celestial comes from the Latin word caelestis, which means of the heavens. The word hemisphere comes from the Greek word hemi and spheria meaning ball. Double the time of sunrise, you get the time of night. So if sun rises at 6 a.m. in the morning, double it, you'll get 12 hours. That is the time of the night. If the sun rises at 10 a.m. in the morning, double it, it's 20 hours. In the northern hemisphere, summer is 4.5 days longer than winter, spring is 3.8 days longer than winter, and autumn is 0.9 days longer than winter. This is the opposite for southern hemisphere. That is, winter is 4.5 days longer than summer, winter is again 3.8 days longer than spring, and winter is again 0.9 days longer than autumn. So today we're going to look at the Olbers paradox. The stars are like suns, and everywhere you look there are billions of stars. Why isn't space filled with light? Why is it black? So this was puzzling scientists for over 100 years when Heinrich Wilhelm Olbers discovered the first asteroid, began working on it in 1823. People soon called it the Olbers paradox. The theorized answer, as there is no end to this paradox, is that the galaxies in which the stars are redshifting so much, that is, as explained in my earlier video, are moving away from the Earth so much that their light is redshifting so much that it has not even reached us yet. And even if it does, the redshifting has a dimming effect on the light the star gives out. So now I'm going to look at quasars. So I'm going to read a short poem by Jesse Greenstein about it. Horrid quasar, near or far, this truth to you I must confess. My heart for you is full of hate. O superstar, implored gas, you glowing speck upon a plate. Of Einstein's world, you've made a mess. So it's a superstar, as said for the poem. Okay, so let's look at how it was discovered. In 1960, two radio astronomers, Alan Sandage and Thomas Matthews, were hoping to find out what the source of radio wave was. It was codenamed as 3C48, that is third catalog and 40th object. Sandage and Matthews aimed the 200-inch Palomar telescope in the direction of 3C48. What they found was a bluish star. I'm using air quotes because it's not a star. But these stars give off radio signals in a very different way that they were clearly not stars. So they were referenced to as quasi-stellar stars. QUASI-STELLAR-STARS. In 1964, Hongyi Chu named it as quasars, as short form for quasi-stars. The word quasi means as if, as we explained in my last video. Jocelyn Bell Burnell in 1967 pointed a telescope at the constellation Vulpecula. She found that regular pulses of radio interferences were there. It came at a rate of every 1/3 of a second for every 1.33728 seconds. It was called Little Green Men, LGM, as people thought that the radio signals were messages from aliens trying to contact the Earth. But after monitoring the Little Green Men for a long time, the astronomers realized that it was just a different kind of star that kept on pulsating. so they were named as pulsars. So theories of pulsars being rotating neutron stars were created at the when the Crab Nebula, nebulas generally have neutron stars in the middle, was found to have a pulsar. It has been theorized that there is over 150 pulsars in the whole entire universe. Now let's look at some random words and their meanings. Acidia Plantia, a dark marking in the northern hemisphere of Mars. It is 2615 kilometers in diameter. Elementary particles are leptons and quarks. These have no subcomponents. 6 leptons are there: electrons, muons, tans and neutrinos. Hadrons are particles with quark constituents. If 3 quasars are there, they are called baryons. Neutrons and protons have structure comprising of triplets of quarks. A black hole of Sun's mass will last 10 to the power 66 years. An extremely dense star that is a mass below Chandrasekhar limit is a white dwarf. The limiting mass for a non-rotating white dwarf is a Chandrasekhar limit. It is 1.44 solar masses for helium-based stars, 1.4 solar masses for carbon-based stars, and 1.11 for solar masses for iron-based stars. The star which exceeds it will be forced to undergo further gravitational collapse to become a neutron star or even a black hole. A neutron star is an extremely dense and compact star. A black hole is an object so collapsed that its escape velocity exceeds c, or the speed of light. A collapsing object becomes a black hole when it has crossed the Schwarzschild radius. So the Schwarzschild radius is the radius of the event horizon to a black hole. It is normally represented as the Schwarzschild radius is Rs is equal to 2 times gravitational constant into mass of the star divided by speed of light squared. So this is Random Facts. I will be posting my review on the Sony NW-A46HN soon, and thanks for the response. It has been awesome, and as I said in the beginning of the video, I have just crossed 589 views. Please continue this. I would hope if it does, and please subscribe. Thanks for watching, and this is Redox signing off.